Okay, so here we have the situation where we are trying to graph an ellipse and figure out the information about it. However, the equation is not in the format with which we're familiar. That whole a squared over x squared plus b squared over y squared equals 1. So we are going to use this, complete the square, in order to turn this equation into this form. So we've done some basic completing the square with quadratics, and it's the same here, except we're going to group the x's separate from the y's, and because the equation of the ellipse has a 1 on the right hand side, we know we're going to take the plane number and move it over to the right hand side. So that's no good. Our first step would be to group the stuff together. So here's our x stuff together and our y stuff together and our plane number on the other side of the equation. So within the x stuff itself, I'm going to complete the square, and the y stuff itself, I'm going to complete the square. Now, most of the completing the square stuff that we did had just so for example, we did something like this where we would take half and square it and add that to both sides. And that worked because the coefficient of the squared term was 1. We have a different situation here where there's a number in front of the squared term and a number in front of the squared term. So this additional step is this. So what I have done, actually I'll just show you this part here. Okay, so what we did is we saw that 4 was common to both of these, so factored out 4, and we were left with x squared minus 6x. And over here, in the black writing, we saw that 9 was common to both, so we factored out a 9 and left it as y squared plus 2y. Okay, so you can kind of cover the 4 up, pretend that isn't there, and you're completing the square with this. So when we're completing the square with this, we're going to take half and square it, meaning look at the middle term or the x term, take half of it, that is a negative 3, square the negative 3 to get 9. This 9 is our kind of our magic number that if we add to both sides, this becomes a perfect square, which is why we call it completing the square. So we take half, square it, that's the number we add to both sides. However, do you see that because we added 9 to this side, the 4 times 9 is actually a 36. This is the step that usually throws students for a loop, so I'm going to repeat A. Half of negative 6 is negative 3. We square it, we get 9. This is what we're adding to this inside the parentheses. However, because there is a 4 outside the parentheses, when the 4 is distributed, it was actually 36 that we added to this side of the equation. So on the right-hand side, I have added 36 to balance it out. Similarly, over here, take half of the middle term, that's 1. Square it, that's 1. Add it. So this is going to be a perfect square. However, I didn't just add 1, I actually added 9 times 1, so in purple plus 9. Aha! Okay. So, on the right-hand side, negative 9 plus 36 plus 9 gives us 36. Over here, y plus 1 squared and x minus 3 squared. Notice, please, how the half that we took is the number in with the variable, and the half that we took is the number in with the variable. Is that always the case? Yes. I have the 4 in front and the 9 in front, and that's equal to 36. We know that for an ellipse we want 1 by itself on one side of the equation, so I'm going to divide both sides by 36, meaning 36 is divided into the 9 and 36 is divided into the 4. So, on the right-hand side we get a 1. 9 over 36 goes to a 1 over 4. And 4 over 36 goes to 1 over 9. So I have 9 here and 4 in this denominator. Okay, equals 1. So this now looks familiar. Equation of ellipse. Let's see if we can figure this out. The center of the ellipse is going to be at positive 3 in the x direction and negative 1 in the y direction. Our A is going to be 3, meaning the distance we go from the center to the vertices in the x direction. Our B is a 1. That is not correct. Good thing we're proofreading. Our B is the square root of 4, or 2. This is how far we go from the center in the y direction. So let us see if we can graph. Alright, so our center is at 3, negative 1. So 1, 2, 3, negative 1. Looks good right there. And in the A direction, so here's our center. I went 1, 2, 3, negative 1. In the x direction, we're going 3 each way. So 1, 2, 3, and 1, 2, 3. This is going to be small. 1, 2, 3. 1, 2, 3, and these are going to be the vertices. And then B is 2, so in the y direction from the center we go 2. 1, 2, and 1, 2. Ooh, hey, easy there. Come on back. I'll erase you. Haha. Okay, we went 1, 2. So if I zoom in, looks like our ellipse, nice and neat. So we could say that our center is at 3, negative 1. Our vertices are at 6, negative 1, and 0, negative 1. Our major axis has a length of 6, and our minor excuse me, our minor axis has a length of 4. So that's completing the square, and I thought I would create this video lesson because these steps tend to get involved and students see them for the first time and think, oh my goodness, that's impossible. But you can watch this as many times as you want and learn it. Enjoy.